Have you ever wondered how the story of one of the greatest minds in history began? Let's wind back the clock to a chilly Christmas day in 1642, in the quaint hamlet of Woolsthorpe, England. There, a tiny, frail infant named Isaac Newton entered the world, a full 3 months premature. His chances of survival were slim to none, yet defy the odds he did, demonstrating the same tenacity that would later define his groundbreaking scientific work. This birth was not without its share of tragedy, though. Newton's father had passed away some months before his arrival, leaving him fatherless from birth. The early years of his life, then, were marked by loss and struggle, a stark contrast to the monumental achievements that lay ahead. But as we'll soon discover, adversity often breeds brilliance, and so, from these humble beginnings emerged a man who would change the world forever. How does a farmer's son end up becoming a world-renowned scientist? Well, let's delve into the formative years of Isaac Newton to find out. As a young lad, Newton was enrolled in the King's School, Grantham. Now, this wasn't just any school, it was one of the most prestigious schools in Lincolnshire. Here, Newton began to show signs of his future brilliance. He wasn't just interested in the typical curriculum of the time. No, he was drawn to subjects that allowed his curiosity to run wild and his intellect to shine. Newton explored law, philosophy, and even ancient Greek mathematics, subjects that were far beyond the comprehension of average students his age. But Newton was anything but average. These subjects fascinated him, and his relentless pursuit of knowledge set him apart from his peers. One of the most intriguing parts of Newton's early life was his time at Trinity College, Cambridge. This is where Newton truly began to blossom. His love for learning intensified, and he found himself engrossed in the works of great philosophers and mathematicians. He was particularly influenced by the works of Aristotle and Euclid, which would later serve as the foundation for his own groundbreaking discoveries. But Newton didn't just study, he also created. One of his earliest inventions was the reflecting telescope. This wasn't a mere school project, it was a significant contribution to the field of optics. This invention was a clear testament to Newton's ingenuity and a precursor to the remarkable inventions that were yet to come. Newton's early years were not just about academic pursuits, they were also about shaping his character, honing his mind, and nurturing his insatiable curiosity. His thirst for knowledge, combined with his unique ability to think outside the box, set the stage for the revolutionary discoveries he would later make. It was during these formative years that Newton laid the groundwork for his future discoveries. What if I told you that the groundwork for modern mathematics was laid during a plague quarantine? Yes, you heard it right. The year was 1665. A year that would go down in history not just for the Great Plague that swept across England, but also for the birth of an invaluable tool in mathematics and physics: calculus. With the University of Cambridge closed due to the plague, a young Isaac Newton found himself back at his family estate. Away from the hustle and bustle of academic life, Newton had the time and solitude to think, ponder, and experiment. It was during this so-called Year of Wonders that Newton developed the initial ideas of what we now know as calculus. But what is calculus, you may ask? In essence, calculus is a branch of mathematics that deals with rates of change in quantities. It's like a mathematical microscope that lets us zoom into the infinitely small or zoom out to the infinitely large. It's the language through which we understand the patterns of the universe, from the orbits of planets to the behavior of quantum particles. Newton's calculus, or fluxions as he called it, was a revolutionary tool that allowed him to formulate his laws of motion and universal gravitation. It was a key that unlocked a new understanding of the physical world. It allowed us to predict the motion of heavenly bodies, design aerodynamic vehicles, optimize complex systems, and so much more. But it wasn't an easy journey. Newton's ideas were so ahead of his time that they were often met with skepticism and resistance. It took years, even decades, for the scientific community to fully grasp and accept the profound implications of Newton's calculus. The plague, while devastating, gave birth to one of the most important tools in modern science. It's a stark reminder that even in the face of adversity, the human spirit can rise and give birth to ideas that shape our understanding of the universe. What can an apple falling from a tree teach us about the universe? This question may seem peculiar, yet it was this simple observation that led Isaac Newton to formulate his law of universal gravitation. Imagine an apple falling from a tree. According to Newton's law of universal gravitation, Every particle of matter in the universe is attracted to every other particle by a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This law, in essence, explains why the apple falls to the ground. But Newton didn't stop there. He also developed his 3 laws of motion, which further revolutionized our understanding of the physical world. The first law, often referred to as the law of inertia, states that an object at rest stays at rest, and an object in motion stays in motion, with the same speed and in the same direction, unless acted upon by an unbalanced force. This law explains why the apple doesn't just hang in the air or start moving on its own. Newton's second law of motion states that the rate of change of momentum of a body is directly proportional to the force applied and occurs in the direction in which the force is applied. This is often simplified to the formula: force equals mass times acceleration. Lastly, Newton's third law, known as the action-reaction law, states that for every action, there is an equal and opposite reaction. This means that any force exerted on a body will create a force of equal magnitude, but in the opposite direction on the object that exerted the first force. These laws changed the way we view the world. They provided us with the tools to understand and predict the behavior of the physical world, from the motion of an apple falling from a tree to the motion of planets around the sun. These laws still form the foundation of physics, centuries after Newton first penned them. How did Newton's later years shape his legacy? Let's dive into that. After the publication of his groundbreaking work, Principia, Isaac Newton's renown grew exponentially. He was appointed as the Warden of the Royal Mint in 1696, and later its master. These roles were not merely honorary. Newton took them quite seriously. He led a sweeping reform of the British currency, tackling counterfeiters head-on and ensuring the mint's efficiency. In 1709, Queen Anne knighted Newton, making him Sir Isaac Newton. This was an honor rarely bestowed upon scientists of his time, further highlighting the significance of his contributions. Newton was also elected as the President of the Royal Society, a position he held for more than 20 years. Under his leadership, the society thrived, becoming a cornerstone of scientific research and discourse. As the years wore on, Newton continued to work and contribute to science despite his declining health. He passed away in March 1727, leaving behind a legacy that would shape the future of science. Newton's work laid the foundation for classical physics, a field that has driven countless scientific and technological advancements. His laws of motion and universal gravitation are taught around the world, forming the basis of our understanding of the physical universe. Moreover, Newton's approach to science, meticulous observation, rigorous testing, and mathematical description set a standard for scientific method. His work exemplified the power of human curiosity and the relentless pursuit of knowledge. In the world of science, Newton's influence is profound and enduring. His ideas continue to inspire and guide scientists today, centuries after his passing. His genius transformed our understanding of the universe, revealing a world governed by laws of physics that we continue to explore and understand. Isaac Newton's journey from a premature baby to one of the greatest minds in history is a testament to the power of curiosity and perseverance. His story, his work, and his legacy remind us that through relentless inquiry and the courage to challenge established ideas, we can make groundbreaking discoveries that change our world. So, what have we learned today about Sir Isaac Newton? We've journeyed through the life of one of the world's most influential scientists, from his humble beginnings in a small English village to his prestigious education at the University of Cambridge. We've delved into his groundbreaking work in mathematics, particularly the development of calculus, which set the stage for much of modern physics. We've also explored his monumental discoveries in the field of physics itself, including his laws of motion and universal gravitation. These laws, which elegantly describe the motion of everything from a falling apple to the orbiting planets, transformed our understanding of the natural world. Finally, we've reflected on Newton's enduring legacy. His insights continue to underpin much of our scientific knowledge today, and his spirit of curiosity and dedication serves as an inspiration for scientists around the world. Isaac Newton's life and work continue to inspire and influence scientists around the world, reminding us that even the simplest observations can lead to extraordinary discoveries.